Okay, so yeah, so I can't turn on my camera because my laptop crashes every time I do it. So excuse me for having no camera, but yeah, maybe I'll just give a quick summary of where we got to so far. So, okay, so yeah, we're pretty much finished this project basically. So we have the generative art repo. It's loading very slowly.
Your voice is going funky again.
So,
It is beyond the camera issue now.
okay, once this web page loads, it should be good. Okay, so you can see this, right?
Nope.
So yeah, I think Aaron, you I think
We
you
can't
joined.
see it, Richard.
Is it working?
Richard, I can't see it, and your
Oh,
voice
yeah, I haven't
sounds
shared my screen.
garbled.
Yeah, that would actually help. Sorry, say again, Aaron?
The sharing screen isn't working. Oh well, I think it's okay.
Now
It's up now.
Yeah, your voice is garbled for a little bit.
Okay. Okay. All right. Hopefully now that everything is loaded, so hopefully my voice will be okay. But again, let me know if it's not. So yeah, this is the generative art repo, and I think Rish, you saw these images, but maybe Aaron, you didn't. So like what we did was we trained a generative model locally a few weeks back, and these are the results after different epochs. So we trained it on CryptoPunks. This was after like 5 epochs, this was 25 epochs, and this was like 100 epochs. And it looks like we might be getting some like new punks and stuff. So basically the training is working locally for our toy problem. So that is one of the images. And then we like created this contribution Kanban board. And so I've kind of been putting up these issues and working through them. And then if other people want to pick up issues, like Jakob has joined in, for example. So this is kind of where we're just keeping up with all the tasks that need to be done and stuff. Okay. So yeah, so after we trained the generative model locally, what we did was we checked out the compute to data flow. So this is like a README doc that Ocean provides. And they basically just do this generic C2D workflow that, you know, you publish the data set, you publish the algorithm, you verify, you allow the algorithm to run on the data set, and then you like give people data tokens and algorithm tokens, and then you run the compute job. So we ran through this a few weeks ago, and then when it's running, you can check the status, and then at the end, the idea is that you get the result of the compute job. But actually, there's a bug in the OceanPy library at the moment, so I'm talking to them. They're taking forever to fix it, but I think that like there were like 3 people stuck on this problem in the Discord. So I think they've made an issue for it on GitHub now. So hopefully they'll finally fix it. But yeah, and then Jakob made some notes in a notebook that he pushed. And as he correctly observed, the notebook is basically, it's a really generic C2D flow example, and it doesn't represent the workflow of a data scientist, because, for example, a data scientist doesn't need to publish a data set. Isn't this? So a data scientist doesn't need to publish a data set. They just need to publish an algorithm. And then like in this C2D flow example, they just like transfer the tokens. So they don't actually buy the data set properly. It's just like a quick hack to give everyone the tokens that they need. And so it's useful to like separate this notebook into the actual workflow that a data scientist will use. And so that was what I was working on this week. And so, okay. And so we want to run the C2D flow for our generative art algorithm as well. So the first thing to do, okay, I'm going to try to load a file now, so you might lose my voice for a few minutes. Yeah, so this was basically the notebook for training the generative model. Can you still hear me properly?
Yes, and are you recording, Richard?
I pressed it, I think.
Okay.
Yeah, it is recording.
Yeah, okay, cool. Yeah, so this was the notebook for training the generative model. And so we downloaded the data set of the CryptoPunks. We defined our generative model. Well, we defined our data set first. So this is like a PyTorch data set class for the CryptoPunks. We then defined our model. So like a generator, discriminator, 2 parts of a GAN, the different optimization parameters. Then we ran training and we visualized the results. And you can kind of see it so this is what it looked like on the very first epoch, and then it kind of trains gradually. And so this is how data scientists often tend to work in notebooks, because you can visualize stuff really easily. But we don't want to run a notebook with compute to data. So the first step is to convert this notebook into a Python file. And I actually did this manually, but in future, we might be able to automate this. So for example, FastAI, they have this GitHub repo that's called nbdev, so notebook dev. And the idea is that you can develop a whole library in notebooks, and then you just press export, and it exports it into Python files and stuff like that. And so we might be able to come up with something similar so that data scientists can develop in the notebook, and then when they want to run the compute, they could just press some sort of export button, and it would format it in the way that it is needed for compute to data. Okay. Right, I'm going to try open up my editor. Give it a sec. So that notebook that we just looked at for training the generative model was notebook number 3. So I've uploaded a file that's number 4, which is basically the exact same file, but in the format that's needed for compute to data. I actually did this 4A. I didn't upload this one to GitHub, but what I did for the first one was I basically just copied and pasted every single cell from the notebook in here. And then I just checked that when I ran it as a Python file that it worked. And then what I changed for the one that I uploaded is that it's pretty much the exact same, except, so if we look here, this is what's called when we run it. So we can do Python, the name of the file. And then if we want it to run locally, we just add a local argument. Or if we want it to run by compute, we just put no arguments. So it's going to check if you have this argument, and then it's going to have a Boolean for whether it's local or not. So this will be true if it is local. And it's going to call this function, which is just run DCGAN. And what DCGAN does, so it has this new get input function as well. So the idea of this is to get the data in 2 different ways. So depending on whether it's local or not, and that's this function up here. So if it is local, we just want to load it in the same way as in the notebook. And if it's not local, if it's compute, we want it to load it from a particular place in the Docker image. And so it's going to be a slightly different format. I haven't actually checked that this works yet, but I got this from the Ocean Pi compute to data example. So, but the idea anyway is that we either load it locally or we load it in the way that we need it from the compute. And then that gives you your data. And then the rest of the file is pretty much the exact same as in the notebook, basically. Does anyone have any questions?
I see all of this is local. You haven't pushed any of this to GitHub as a public repo yet, right?
I think I did. I think I pushed this on the notebooks.
Oh, you did? Oh, okay. Is there a way? Let me see. Oh, so it's just this link, right? Let me see, put this in the chat if this is the correct one. I just have to dig in. Okay, under notebooks. Okay,
and even
great.
so, this
Now,
is the
beautiful.
Python file here as well. This is the one we were just looking through.
Got it. Got it. No, this is awesome.
So this should run as well, which I'll show you in a sec. So yeah, basically that is this is the file that we're going to run. It does the same thing as our notebook, but it's now in the format required for compute to data. And so now that we've created this Python file, I could run these locally as well, but I don't want to in case my computer dies. But you can run these locally in the command line as well. So I could run this command and it would run. I could do local. So I could run that and it trains. Or I can like set up the Docker image as well. So I guess that's the other thing we need as well. So to use compute to data, you have to run this in a Docker image. And so I created a Docker file. So what you can actually do is, like, I created these scripts as well, which I haven't pushed yet. But yeah, we can run this command. So like Docker run, loads of arguments. This is the, hold on, forget, we saw this for a sec. What you can actually do is you can just use the PyTorch Docker image. So you could like run this Docker image and then you can run the exact same file from within the Docker image. And the thing with Docker images is that we need to mount different things. So if we want to use a data directory, we need to mount the data directory. And then I also want to mount the results directory so that I can get the results back. But yeah, so like what I could do is, like I said, I could run the Python command out here, local, or I could do the script. So I could run this command, which sets up the Docker container. And then when I'm in the Docker container, I can just run the Python command, and that works as well. So yeah, like I said, you could use the PyTorch Docker image, but we actually need a custom one because the PyTorch Docker image doesn't have matplotlib installed. And so if we want to plot images, it doesn't work. And so what I did was I started to define our own custom Docker file, which basically starts from the PyTorch Docker image. And then basically installs some different packages that we need. And like, this is just like basic bash tooling. So if we want to use like Vim, for example, or some other stuff, this just installs all of that in the Docker image in case you want to use it. This might be a bit heavy. We could probably remove a bit of this, but this is how you define a Docker file, basically. And so I defined this custom Docker file, and I called it a very particular name because I want to push it to Docker Hub. And so Docker Hub is like GitHub for Docker images. So what I did was I set up an Algovera Docker Hub, and I created this repo called Algo Dockers. And this exactly matches Ocean Protocol Algo Dockers. And so in this repo, I created a image that's called generative art, which is basically just the one that you just saw. And so now that we have a Docker Hub, what people can do is they can basically just go Docker pull Algovera, Algo Dockers, and then the generative art. So now anyone should be able to do that, pull the Docker image, and then, so you don't need to recreate it. And then you should be able to just do Docker run with the script, and that will run our Docker image basically. And so like, depending on what the algorithm is, maybe we need a different Docker image for each algorithm, for example. And then this is the place where people will be able to download and run them. Does anyone have any questions about that?
So, I mean, I don't have questions on the code. I'm just thinking about issues like, so we have to have the data sitting on the same compute server, right?
The data, yeah. Well, it's on the Ocean marketplace, and then
no, it's on but over here in your in the other Python file that you showed, wasn't it?
Mm-hmm.
Yeah. So where do you have the data there?
Yeah. Yeah. So like, I guess we would have the sample data locally. So if it's a private data set, you can still access the sample data. And so the idea would be that you could download the sample data, make sure your algorithm runs on the sample data, and then create the code and run it on the full data set. But we've kind of cheated because I can like train locally on the full data set, which I actually wouldn't have access to.
Okay. And you could have the data somewhere else, right? I mean, if it's a private data, this file would still be okay to run, right? Oh.
Yeah, so the idea is, well, we can always download the sample data, and like what the data publisher should do is publish the sample data in the same format as the full data set. And so if my algorithm runs locally on the sample data, then I can send it to the full data set and it should still run.
Okay. And then you have to have a Docker, like the Docker hub thing, is it?
You have to, yeah, if you want to run compute on the Ocean Marketplace, you need to give it a Docker image. And so I'll show you here. So that's the next step. So yeah, so in the C2D flow example from Ocean, it like has all of this in one, but we're going to separate it into publish algorithm, approve algorithm, and then run the compute job. And so this is just the publish algorithm part, which builds on the notebook that Jakob was working on. And so we need to give the algorithm metadata. And so that includes a URL. So in our case, that is just going to be the exact same Python file that I showed you that's in the repo. And the only difference is we need to do the raw format. So if we just did github.com here, that would be like HTML data. And so we use this format so this should just be a text file basically. Let me show you. So you just get text. And yeah, so then this is the name of the image. So Algovera, Algodockers. So that's like the name of the repo, which is this one here. So that's now available to everyone when they want to run a compute job. And then this is the tag, like so the tag within the repo. So ours is the generative part, which you can see here. And so, yeah, you always need to give it. So container, this is where the image and the tag go. So you always need to give it a Docker image to run. And so you could also use, if you didn't want to use the Algovera one, you could do like Ocean Protocol. Oh, it's the exact same name as the repo. And then I think theirs is called like Brannon. Or like Python Brannon or something. Can't remember. But yeah, you need to give it a Docker image.
Just how does publishing the trained algorithm differ from publishing the algorithm to train to run a compute job? Like, once the algorithm is trained, do we just run the same code and update the algorithm we already uploaded to train, or do we have to publish a new algorithm?
It's a good question. Yeah. I guess like maybe you could pass it an extra parameter or something like that. So maybe like, I think at the moment, maybe you would publish a different algorithm. So you'd have like a training version and maybe like an inference version or something like that. But I can see in future that you could pass another argument that said like training equals true or training equals false or something like that. It's a good question.
So that's maybe something we can that's maybe a point for the Algovera marketplace, that there could be just so the marketplace doesn't get like cluttered with empty algorithms that are not trained.
Yeah.
It would be good to somehow filter them.
For sure. Yeah. And actually like even outside of that, all of these parameters for training, like how many epochs you want to do and stuff, I think at the moment with Ocean, if you wanted to change a single parameter, you would have to have a different algorithm for that. And so I think I just went to the core tech meeting for Ocean the other day, and they're basically trying to prioritize features that they need. And one of the ones that they were prioritizing was this ability to, pass training parameters to the algorithm as well. And so I think they're working on that. So I guess something like training equals true or training equals false could be another thing that you could pass to it, so that someone else might solve that basically.
Okay. Also, how do we can we make how do we explore the GAN space in the trained CryptoPunks model? Because maybe what would be cool for like the Algovera Academy was maybe like selecting, as you said, like selecting which hat you want to add to your CryptoPunk, or
that'd be
which
great.
other accessory.
Yeah, like I think we can get creative with this. So like Holly, who's the artist that has joined some of the hacking sessions, she sent me a link to some different repos where you can explore the parameter space of algorithms. So like that's on my list of things to look into. But and then like the way that we do that, in like, so for example, there's this Abraham project that we've talked about, Jakob, and it's like their idea is that they have this generative model, and they say that each week or each month, the generative algorithm is going to generate 10 new samples, for example. And then they have a vote on which samples they want to run the generative algorithm on. And so like, I guess we could do something similar where you have this latent space, and maybe it looks like, I don't know, a map or something like that. And like everyone votes on where in the map we want to look, promising regions or something like that. Because if we, let's say we create a web app, which I was also looking into last week, but let's say we create a web app to showcase our generative model. In the back end of that web app, we want to have an algorithm on the Ocean Marketplace, so that every time the web app is used, some sort of fees go back to the algorithm token holders, for example. But there's also like, do we want to give the users the first example that is generated by the model? Or do we want to give them some choice? Like maybe they don't want to take the first image that's generated, for example. So maybe we need some different way for them to explore the parameter space to choose one that they like. But if we want to explore the parameter space, then that each time we explore, I think it means like running the generative algorithm. And so we need to come up with some sort of clever way for people to be able to pick what they want, but also not like pay a transaction fee each time they look at a new one or something like that.
Maybe could that be done by like allowing them to run any number of generations, like on Ringby, and then I guess, but there's the cost of actually generating them, like in the decentralized compute, I assume.
Yeah, and if you provide the exact same algorithm on the real net and the test net, why wouldn't people just use the test net every time?
Yeah. I was thinking that like if people actually wanted the punks to have a value, they would run it on the mainnet. They could like right now the data is on the testnet, so you don't have to really pay to get access to that data set. So I thought that maybe it could be something similar with that, with the actual generation, and also like relating back to like the academy, like in terms of like an onboarding process, if it was just like there is some value in just like generating NFT on the testnet and giving it as a POAP, which doesn't really have any monetary value. But that, I mean, that would mean that we couldn't really sell the NFTs. Also, another thing, maybe, do you know what the workflow is to like automate publishing these the NFTs generated by this GAN to OpenSea? I think there was this guy in Absentia Discord who was also doing like who trained a generative model for art, and I think he had like an algorithm to also publish them automatically to OpenSea, and I suppose that's something that Abraham AI does as well.
Yeah, I'm not sure actually. I haven't looked at that part. from what I hear, it's pretty easy to publish on OpenSea. So like, I guess maybe they have APIs and stuff like that. But what might be difficult is making value flow back. So once it's published on OpenSea, if that NFT swaps hands, like how do you direct a flow of value back to the algorithm token holders, for example? Is that possible? I'm not sure. So like, I think, yeah, once we really start mapping out the web app and everything we need to put together, I think all of this sort of stuff will become more clear. But yeah, I'm not really sure like what we need to build and what's already built. But
Yeah.
just publishing the images, I think, should be okay.
Okay. Yeah, I was also thinking about this in terms of like the different projects that can spin up in Algovera, because when somebody's just building an AI model that for somebody else to use, like they will upload it to the marketplace, then the value flowing back is easier to imagine. Like you have some transaction fees from the marketplace that go back to the treasury. But what if there are squads who are developing models that you will just automate, and they will just run on the blockchain trying to, say, publish art, or perhaps some like DeFi trading algorithm, like that's, I was thinking how like the value could flow back in these like plug and play models where people wouldn't really buy them. They would be like it would be more like the data scientist training the model so that then it generates value on its own.
Yeah. And like, yeah, you just unleash it into the world.
Yeah.
Yeah. That's another interesting one as well. Yeah. There's so many options, like the design space is so big, and we just need to figure out like what we can build and like what makes sense to build first, I guess. And we're getting to that stage as well. Now that the compute is pretty much wrapped up and we're starting to build the web app and stuff, I think these are all the really interesting questions that we can start to ask. Cool. Okay. So yeah, basically you just give, when you're publishing the algorithm, give the code, give the Docker image and the tag, who's the author, and then like give it a name as well. And so this is all the metadata. And then, yeah, you basically just create it. So just publish on the blockchain, and then you can check it. And this is what it looks like. So you can actually check this on the Ocean Marketplace now. So yeah, that's publish algorithm. The next step then, as I said, like from the C2D notebook, is that if you want to run an algorithm on a data set, the data set owner has to approve that algorithm to run first. And the reason for that is because the algorithm could do something malicious, like for example, copy all of your data or something like that. And so like, I think this is done manually at the moment. But like, there's all sorts of ideas for ways to improve this, like reputation-based systems and curators and stuff like that. But for now, I guess like there's not that many algorithms being sold, so it's not that big of an issue at the moment to check algorithms manually. So yeah, this was in the C2D notebook as well. Basically just define the asset. So this is the identifier for the data set, the identifier for the algorithm, and you just run this like function that just adds it to the trusted list. And what that should do is, if you click on the data set, this algorithm shows up on the right hand side. But it hasn't worked at the moment for some reason. I think maybe it just takes a while. But once we've approved it, like the data set that this algorithm runs on should show up here, and vice versa. So if you check the data set, it should show the algorithm that runs on it. So either there's a bug or that will show up in a while. I'm not too sure.
Yeah, I was trying that once I got it working, and for me too, it never showed. Like you expect to see
strange.
the algorithm there, and it doesn't show there. So
it's weird. Yeah, because it worked for me before, and so maybe it's a bug. I would reach out to the Ocean team, but they seem to be really slow with these issues. So yeah, like Ocean is still quite buggy just because it's still in alpha, and so like stuff breaks all the time. So hopefully they get their shit together, but or maybe just iron out all the bugs, or maybe we just fix them. Okay, so that was verifying the algorithm, and then the final step is actually running the compute job. And so this is similar to the C2D notebook as well. So yeah, just set it up, create the wallet. So we just like define the identifier for the dataset again. The next step that's different to the C2D notebook is, so in the C2D notebook, I think they just like transfer the data tokens and algorithm tokens to the data scientist. But in this case, we actually want to buy it. So the first thing I needed to do, and we can probably streamline this again, but if you want to buy a data token, you can do it through the graphical user interface, or you can do it through OceanPy. So what I did was, you don't buy the data token from the data token address. You actually buy it from the pool address, and so you need to give it the pool address. And so what I needed to do was go to the marketplace and click on this pool arrow here, and then it goes to like Etherscan, and then you just copy the address. So this is a pretty clunky way of doing it. So I don't know if there's an easy way that we can, if we know what the data token is, how can we get the pool? I would have assumed there should be a function for that, but I couldn't find it when I was looking quickly. And so that's why I needed to go through the app itself. But like, there's probably a better way that we can do this. So I just defined the pool address manually, and then I can print how many of these algorithm tokens are in that pool. So this depends on how you set up the pricing on your data set. But in the liquidity pool that I created, it starts off with 9 data tokens, and these are this is the CryptoPunks data set, by the way. And so like, you set up a pool like with 9 CryptoPunks data tokens, and then that pool also has some Ocean in it, which is like, I think it's 9 to 21 or something like that. So we just checked the pool. That's how many data tokens are in it. Now we can actually buy one of those data tokens from the pool. And so we want to buy this as a data scientist. So we give it the pool address, the amount that we want, and also like the max that we're willing to pay for it. And then we give it our wallet as well. And so this is just the command that's the exact same as pressing buy data token in the Ocean market. And so, oh yeah, I also checked up here, like I checked if we had any data tokens first. So it said we have 0, then we buy it, and now we can check again, and we have 1 data token. And so the next thing we need to do is we just publish the algorithm. Publishing the algorithm is only the first step. You then need to create pricing for the algorithm. So this is basically, creating the pool and stuff like that. And so I'm not sure if there's a way that we can do that through the Ocean Python library. I just did it through the graphical user interface again. So you go to when you go to your algorithm initially, so you can see I've already set up the pool now and stuff. But when you go to this initially, it basically says set up pricing. It looks like this, create pricing. And then what you need to do is, I'm trying to think if I have a picture saved of this. Don't think so. It's like asks you what parameters you want to set up the liquidity pool with. So how many algorithm tokens do you want to put in compared to Ocean tokens and stuff like that. So you just go through a few steps. You have to like confirm with your wallet a few times. And then after you do that, you can like check the pool and all this sort of stuff. So I recommend that everyone goes through that process as well. But yeah, it would be cool if we could do this through the command line as well. Because again, if we want to automate this, we don't want to go through the web app each time. Okay, so we've already defined which data token we want, which is the CryptoPunks. We can define which algorithm token we want, like so find the identifier. So we get that. And we like the data scientist already has algorithm tokens because we created it. We created the algorithm, so we have algorithm tokens. And so If you didn't, you could just like buy them from the algorithm pool, the same way we bought the data tokens. And then finally, so we have, like, I guess you need like one algorithm token and one data token. And when you have that, it means that you can order and pay for the data set. So we have one data token, we need like one algorithm token, and we order and pay for both of those. And then we set up our compute job. So we give it the inputs, so which data set we want, like I guess proof that we've bought it. We tell it which algorithm we want and proof that we've bought the algorithm. I guess you point to the transaction. And then you can just press run. Oh yeah, so this runs it, and then you can check the status. So you can kind of interactively like check this again and again. And then, yeah, at some stage, so when it starts, it says like creating volume. So that just means like setting up the Docker image and stuff like that. Then it will say running algorithm. And then finally it says job finished. And then once the job is finished, you should be able to retrieve the results. But again, this is the same bug we saw in the C2D flow. And so at the moment, it basically says server error. So, but they're working on fixing this now. So once this is fixed, we should be able to retrieve the results. And then we should be able to like look at the images. So like what the generated images look like from the CryptoPunks and stuff, get like the loss curve. You can also retrieve like the logs from training as well. So if something broke, I guess it's gonna like tell you what broke and stuff, so you can debug. And so, but anyway, yeah, the algorithm runs, we just can't get the results back yet, but like that should be fixed soon. And then, like I said, the last step is going to be, yeah, just check the logs and results. And so some of these, the reason that these aren't complete yet is because we need to retrieve the results. And then once we retrieve the results, we can check the logs and like plot the images and stuff like that. And that means we'll have done the exact same thing as we did in this notebook with training, but we'll have done it using compute to data. And so we can only, the other thing is we can only do like 5 epochs at the moment because the ocean compute times out after 60 seconds. And so I calculated like 5 epochs takes 40 seconds or something. So we should be able to do 5 epochs of training. So that's what we're doing at the moment. But if we want to train for longer to get the nice images that we saw like here for 100 epochs, that takes much longer than 60 seconds. So that means that we're going to have to provide our own compute. So we need to change the compute provider from the default of Ocean, and we're going to use Robbins from Data Union instead, because I think he has lots of AWS credits. But eventually we're going to need to figure out where we can get money to buy our own compute, I suppose. But yeah, so that's pretty much the training. And then maybe we'll like publish an inference algorithm. So like how you usually create an algorithm, you train it first, obviously, and then it's trained, and then all you need to do is just run inference on it. So our web app won't do any training. It'll probably just run inference basically. And so that's pretty much the exact same code. But yeah, so like maybe we'll publish that as a new algorithm, or maybe we can sort out the arguments like Jakob was saying, and then start to build our web app around it, I suppose, which I was always also looking into a bit. But yeah, I don't know, maybe we can leave it there for this week and just chat amongst ourselves. Does anyone have any questions from that last bit? Okay, that's good. So yeah, I guess like we kind of done a lot of this stuff in the C2D. A lot of the magic happened earlier, like with like the training, like this was a nice visual, and then going through the C2D for the first time. All we've really done now is just like separate that C2D flow into separate parts. And the idea is that like each of these notebooks, maybe we can turn this into a function. And so, yeah, like what we hope to do when we finish is to go back through all of these notebooks and figure out like how much of this code is boilerplate and how much can we take away. And like, that's maybe when we start building our own libraries on top. Like, for example, you know, do we need the data scientist to deal with all this wallet stuff? Because that's a bit annoying. Like what you have to do at the moment is you need to go into Linux like before you run the Jupyter notebook, you need to export your private key. So you need to go into like your MetaMask wallet, export your private key. It says, are you sure, really sure you want to do this? Because it's like, because it's, you're not supposed to do it. And then, yeah, then you put it in bash, and then you use this os.get environment command. So this is probably like not great practice as well, to have people exporting their private keys. Like you wouldn't want to do this with a wallet that you have actual tokens in. And so how can we make this better? Like some of our ideas are create a Jupyter notebook that works with MetaMask, for example. So like that's one idea. Then like downloading the data sets and stuff is all really clunky as well. So we have to like define these identifiers and stuff. So maybe we can just have a catalog of different data sets that Algovera recommends, and like maybe a catalog of algorithms. And so, yeah, like the next step basically is just to go through all of these notebooks, figure out like, how can we simplify it and make it as easy as possible for data scientists to use? Because at the moment it's pretty clunky. Yeah, and then also create the web app, obviously. So, but yeah. Cool. So I don't know, Erin, maybe do you want to talk about fundraising for a bit?
I would recommend hitting stop record. Yeah.
Yeah. I